Hello everyone. So in this lecture, we will see the fifth problem, that is consider an input x of n and the unit impulse response given by. Okay, so the input is x of n, that is equal to u of n, right? So u of n is what? Unit step sequence. H of n, the impulse response h of n is equal to, again it is a unit step sequence. Okay, so write the definition of the given signal. So we know what is u of n. So u of n is equal to, its value will be 1 from 0 to infinity. So x of n is equal to x of n is equal to 1 from 0 to infinity and 0 elsewhere. Similarly, h of n is also u of n, so it is 1 from 0 to infinity and 0 elsewhere. So what is the range of y of n? So y of n exists in the range 0 to infinity, that is at the upper limits. Okay, then at the lower limits, this two, right? So we'll get what is the range of y of n. So y of n exists in the range 0 to infinity. Then draw the sketch x of n and h of n. Okay, sketch it. So we know that its value will be from its value will be 1 from 0 to infinity, x of n. Similarly, h of n is 0 to infinity. Okay, height is, strength is 1. Next step, the first step is what? We have to replace n by k in both x of n and h of n. Okay, so in the sketch, replace wherever n is there, replace by k. Okay, that is the first step. Next step, take the time reversal of either of the signals. Either you can take the time reversal of x of k or h of k. Okay, right? If you take the time reversal of x of k or h of k, you will get the same answers. Okay, it is left to you, right? So I will take the time reversal of x of k. So x of k is what? X of k, that take the time reversal. So x of minus k will be this, the time reflection, right? Similarly, then we have to take time shifted. So just add for this base indexes, just add n. So n minus 1, n minus 2, n minus 3. So this is the sketch of the time shifting and time reversal. Okay, so with this we'll get. Now we have to see whether it is overlapping or no. Okay, whether it is overlapping or no, we have to see the output now by of n, right? So if you see this, the condition 1, if n less than 0 means, n less than 0 means if n value is minus 1 or minus 2 or minus 3. Suppose if I take n equal to what? Suppose if I take n equal to minus 1. Okay, so this will be at minus 1, this will be at minus 2, this will be at minus 3, minus 4, right? So if it is at minus 3, then it will be at in this position, right? So it will be at here, here, here. So it will be at this position, n minus 1, n minus 2, and so on. So whether there is overlapping in this between the two signals, that is h of k into x of n minus k, there is no overlap when the condition is n less than 0. So there is no overlap. So y of n is equal to what? 0, because no overlap between h of k and n minus k. Okay, so that's why it is y of n is equal to 0. Okay, then see the next condition, when the condition is n greater than equal to what? 0, means you can take n value, that is you can take n value as n value is equal to what? You can take any value that is greater than 0 or equal to 0. If I take n equal to 1, right? If I take n equal to 1, then this will be this n will be at 1, this will be at 0, this will be at minus 1, this will be at minus 2. If n equal to what? 1, you can take any value. Either you can take n equal to 1 or n equal to 2. Okay, so if I take n equal to 1, then the overlapping part will be what? So suppose in this example I have taken n equal to what? 2. So this n will come to 2, this n minus 1 will come to n that is 1, then n minus 2 will be at 0, n minus 3 will be at minus 1 because it is 2 minus 3, so it will be at minus 1. Okay, so which is the overlapping part? The overlapping part is from 0 to this value. Okay, from this point to this point is overlapping part. So 0 to n, 0 to n. This edge, the leading edge, and this the trailing edge of this leading edge. Okay, and the trailing edge of x of n minus k. Okay, x of n minus k from 0 to n, from 0 to n. Okay, so that's why we have written here as y of n is equal to k equal to 0, because 0 to n, because this is the ending part of n, so it is 0 to n. Don't take 2, okay, because again we have the samples here for x of k, so the ending part is here. Ending part is what? N. So 0 to n. So k is equal to 0 to n, 1 into 1, because the height of both the signals are same. The strength of both the signals are same. So it is 1 into 1. So that is equal to. So I told you when we have a constant here like this. So what is the formula? It is upper limit minus lower limit plus 1. Upper limit minus lower limit plus 1. So upper limit is n. The lower limit is 0. So n minus 0 plus 1. So it is n plus 2. Okay. So that is y of n is equal to n plus 1 for the condition n greater than equal to what? 0. So in general we write y of n is equal to 0 when n less than 0 and n plus 1 when n greater than equal to what? 0. So this is the condition. This condition shows that it is nothing but u of n. So in general we write, right, because u of n is nothing but what? Greater than equal to what? 0. So y of n is equal to n plus 1 u of n. Then we can sketch it. Okay, so you know what is u of n? So u of n start from 0 to infinity, right? U of n will start from 0 to infinity. So if I put 0 first here, what is the value we'll get here in this? We know what is u of n? U of n from 0 to infinity. It will start from 0 to infinity. So if I put 0 in this, if I put 0 in this, what is that? N equal to 0, 0 plus 1, 1. Then put 1, 1 plus 1, 2. Then you put, so we'll get 1 here. Then if I put 0 of n equal to 0, you'll get 1. If I put n equal to 1, you will get 2. Right? If I put n equal to 2, you'll get 3. If I put n equal to 3, you'll get 4. So this is sketch of y of n. Okay, so we'll stop it here and we'll see some more problems in the next class.